All right. So without further ado, let's get started. So I have some notes here. I'm writing it in comment form. I do that by bringing the 2 dashes, which is very standard with JavaScript. So there's a lot of similarities in Solidity between JavaScript and C#. But if you want to write these comments, go ahead and you can do that by adding 2 dashes beforehand and writing them out. Or you can just check out what I have to say. So we're making a voting contract, right? And there's 3 things we need to consider. So we want the ability to accept proposals, right? So we want to take these proposals, these ideas that people have, and we want to be able to store these ideas. We want to access these ideas. And the proposals, what are the most important things we want to grab from them for when people vote? Well, we're going to have metadata. So we're going to have their names. So we want the proposal names. And then a number or way to keep track of each proposal. All right. So these are going to be the proposals. The second thing we want to make sure we have are capabilities for our voters, right? So we want to have some kind of data to store what the voters are, what they do, and then also their ability to vote, keeping track of the votes, right? That's a big one. And then the authentication of the votes are important too, right? For instance, we want to make sure that only the people in our Telegram have access to vote. We don't want any strangers to be voting that are not part of our community. We don't want people to be cheating. We don't want double votes. We want to keep it fair, and we want to do our best to create code so that the system runs and runs efficiently, right? And number 3, we want to have a chairman, or we want to have some type of force or some type of person, entity, representative, we could even say, that can be authenticating. So we're going to create a chairman in order to keep track of the whole process, right? An elected official to keep track of things. And finally, let me just ask you something. And this should be an interesting question. So why DApp? All right. Why smart contract? I mean, besides the fact that it's fun and we're learning how to do it and there's job opportunities out there in blockchain and it's cool and you can learn a lot by going through this video with me, but does it make sense? And this should always be the first and foremost, most important question when you're building a project. What is the benefit to do it in this way? Why choose this tech stack? Why take voting and bring it to the blockchain? All right, so you can pause the video and think about that for a second. All right, so maybe you already know, maybe that's why you clicked on this video and you're saying what, or maybe you have no idea. For me, what I see to be the main benefit is the fact that it is, of course, decentralized voting. And it's decentralized database voting, right? So the power here is in its security, right? You have security here because this seems like security is greater than, but you get security here because you reduce manipulation, all right? Because we reduce that manipulation, right? Because if it's decentralized, no one authority can go in and change what the information is, right? Immutability is important. So moving votes from applications where people can easily mess with the data to moving it to a place where it's decentralized, that is a fantastic use case for building a DApp. It's real problem solving, not just for Telegram communities, not just for companies, but for governance as well. Okay, so I'm just going to get rid of that. We're going to keep these 3 pointers and come back to it as we're coding along. Of course, our code is going to be much more robust than this, but let's just get started so we can see all of that working together in action. Okay, so the first thing that we want to do is actually bring in Solidity. So we're compiling down Solidity, and we let our compiler know that it is Solidity. And this is very helpful when we are writing out the language, that we instantiate the language to maximize the efficiency of our code. So in order to do that, we bring in a pragma. So we write pragma Solidity, and then we want to follow it by the version. So what we can do here is we can say pragma, the version of Solidity should be, let me make that bigger so you can see it better, should be greater than or equal to, and then we bring in the version. So we want 0.7, in this case 0.0, and less than 0.9.0. So any version between 7 and 9 of Solidity, including 7 and 9, should be running in order to make this code work. All right, so that's just covering our basis, and this is just how we bring in Solidity. We bring it up in the first line. You want it always on the first line. And by having this, we now can be writing our code safely and securely in Solidity. Everything under here is going to be in Solidity. Okay, so I'm just going to start coding after the comments. So what is the very first thing that we want to do? Well, we're building a smart contract. So we actually bring in a contract. We define this in Solidity by writing in contract. So Solidity is a static language, so you explicitly declare your types in Solidity, and you get used to it actually. Even though sometimes it can be a little bit of a nuisance. So we name our contract. So we bring in contract. Now we give it a name. So we're going to call it ballot. And then we bring in these curly brackets to create the data type, the structure, the data structure in here. So everything inside our contract now is going to be the information that holds our contract, right? So this is all the code goes here. Excellent. All right, so let's think about it. So we want to build a voting system. So we talked about these proposals, right? So why don't we start with these proposals? How do we flesh out these proposals? How do we write this out? Well, the first thing that for our proposals, we're going to need to have a name. So we could have a string and make it a name. And we're going to have maybe an integer to keep track of the numbers. So we're going to create a uint, which is for integers. This is for string. And say, okay, uint, and call it something to keep track of our vote. So vote count. Okay. And remember, every expression in Solidity should end in a semicolon. That just means that just tells Solidity again explicitly that this statement is done. Move on to the next statement. And it's quite sensitive to this, so it's important for you to be writing these in. Well, we could do that, but what would be much more efficient in this case is actually to create an object or our own data type, because string is actually a data type. Uint is actually a data type that's held in storage in Solidity and then is defined. But what we can do, if we know that we're going to have multiple things, okay, multiple properties that are going to go into something that we're creating, then it makes sense to us to actually build our own structure, our own data type structure. And how do we do that? Well, we can do that by actually doing that, creating our own data type struct. And we can just do that by typing in struct and then naming our struct. And we're going to call it proposal, right? And then bring in curly brackets like we did for the contract. And then wrap around all the information that we want to carry in proposal. So much like an object in JavaScript, now we can access this information. And we store all this information in proposal. Now, if that doesn't make sense yet, don't worry, because we're going to be using this proposal and accessing it as we go along. But this is important and something to take note of. So we have our struct here, and let's just comment in. This is going to be the number of accumulated votes, okay? And the name is going to be the name of the proposal, the name of each proposal, okay? And what we're going to do also here is we're going to think about this string. Well, if we use string, we have to remember that everything we do when we build our smart contracts and we execute our smart contracts are going to add to our gas transactions. Now, what are the gas transactions? Well, if you go to your deployment over here, we're going to see that we have this gas limit set to, what's that, 30 million? 1, 2, 3, 4, 5, 6, 3 million, right? Okay. So we have this gas limit at 3 million. And this isn't ETH, this is done in Way, right? So what is 3 million? Well, the gas limit is essentially just a protocol, right? Now, why is this important and relevant to the smart contract that we're building? Well, think about it. We're building smart contracts that are running gas transactions. So the more that we're putting in and the information that we put in to run these transactions, how often we're running these transactions on the smart contract, in the interaction of it, and what we're bringing in can actually affect the price of the gas transactions, the gas fees. and therefore an efficient smart contract is going to take this into account, and the best code is going to be the code that is the most robust, but that also offers the least amount of gas fees. So the reason why I'm saying this is that yes, we could write in string for the name, okay, but there is a way to actually save gas fees, and instead of using a string, which is going to do a larger transaction overall because it encompasses more, we could actually use bytes. Okay, so we're going to switch string to bytes, and we're going to use 32 bytes. Well, bytes are just the basic unit measurement of information in computer processing, okay? Let me just say bytes are basic. Oops. Somehow I turned on Siri somehow by typing in bytes. I guess Siri is interested in bytes. Okay, so that's what bytes are. Okay, so we're going to use bytes. Now everything, of course, isn't free, even if you're reducing the cost. And what do I mean by that? Well, because we're using bytes, bytes aren't a string. They're not converting everything to our keyboard. So we're going to actually have to format this code. We're going to have to actually format the proposals from bytes back to string format, back to Sigma in English, so back to your Sigma so we can understand what it says. But we're going to write out the functioning. We're going to write out the function to do that together, and I'll show you how to do that. I'll show you how to do that using Node. So the other thing you're going to want to have in order to fully complete this video is to run Node. You can go download Node by going to nodejs.org and then downloading it and following the instructions. But don't fret, even if you don't have Node or you don't feel like getting it, we can still run through this and you can check to see that everything's working at the end by switching things back to strings from bytes, and I'll show you how to do that as well. It's really not a big deal. But the reason why I'm going through this is because I do encourage not just learning the code, but the best practices and thinking about what's important while we're writing, right? And I think that saving on gas fees is something that's important, so pointing it out. Okay, so that's our struct for our proposal. So we've created a structure for our proposal. Now we need to create a second structure. And let's just write this over here, actually, just so we have the notes. Struct is I think it's a method to create your own data type. Okay, so that's what structure is. I'm going to get rid of all the code goes here. I think we know that by now. So structure is a method that essentially helps you to create your own data type, allows you to do that. So we have our proposal structure. Now what's the other struct that we should also make? Well, let's make one for our voters, right? We have a struct for the proposal. Let's also have a struct for the voters. And I think it's even more important for the voters because we're going to want to do a couple things, right? We're going to want to keep track of whether or not they voted. So for voters, voted, access to vote access to vote, check, giving them access to vote, not to vote. And then also keeping track of the vote number, the index. So vote index. All right. So where are they voting on what, which voter? That's important as well, all right? So voted, access to vote, and vote index. Now, I want you to just pause the video and think about what type of data types should all these be? What kind of variables should we set these to? So go ahead and think about that. Well, voted, right? Voted, have they voted or have they not voted? What is that? That should probably be a Boolean, right? Boolean is a true or false statement. So we call it bool in Solidity. So voted should be a bool. Access to vote. What should this be? Well, you could say, access to vote should be true or false. Yeah, we could do it that way, but what could be more scalable for our code in the future, I think would be to do it as an integer. Because then we can say, well, if they have at least reached a certain number, then they get to vote. And that way, in the future, if we want to add other features such as delegation, and where we get the code from, this actually comes from a template in the IDE. They have this delegation feature, and we're just running through their codes. But instead, we're going to go with an integer. So we call it uint, all right? And uint is essentially declaring in Solidity something as an integer. Okay, so we use uint, right? and then vote index. And what should vote index be? Well, it's keeping track of numbers, so that should be uint as well, right? All right, so go ahead, pause the video and write out the struct for voters given these 3 important properties that we want to be adding while I have a sip of delicious coffee. All right, so hopefully you had some success. If not, let's just do it together anyway. So we're going to create a struct. We're going to call it voter. And we're going to have a voted. All right, so we're going to have a Boolean, which is voted, right? And we already wrote what that is. And remember, we have to close our statements, Boolean for voted. So access to vote, so we're just going to call that vote. So we're going to have a uint vote, all right? And then we want this vote index. So access to vote, that's a uint. We're actually going to call this weight. You could call this something else, but the weight, the amount that we're holding of the power for them to vote. So 0 is no weight. 1 is the vote of 1 weight. 2 can get more than if we're delegating. So weight, and this is going to be uint, right? And then finally, we want vote as well. And actually, let's just put this at the top so we can do another uint for vote, oops, and semicolon, right? So we've got uint for vote, Boolean for voted, uint for weight. All right, and this is our structure for voter. So now we can actually access this information. So within voter now, we can grab voter.vote, we could grab voter.voted, we could grab voter.weight, and we're going to see soon why this is very valuable. Okay, so these are our 2 important structures. And let's sort that. And remember to keep everything in our contract, right? Don't go outside of the scope of the contract. Now, here's the next thing to consider. Our proposal over here has a name and has a vote account, but this is just a structure. Well, we're going to have more than one proposal, right? We're going to have many proposals, you know? Hopefully there's going to be more than just one. You know, people are going to vote, oh, I want to vote for Tim to be the new lead developer. I want Fred to be or Susan to be the new lead developer. I want a new coffee machine in the office, you know, or I want office supplies, blah, blah, blah. So we're going to have many different things. So this can be the structure of what proposal is, but we actually want proposals to be a place where we can store each proposal, right? So how do we do that? Well, we can actually create an array. All right, this is an array, and an array essentially is a place for you to store information, such as lists. So in an array, I can add, for example, strings like color, red, blue. I could add numbers, you know, 1, 2, 3, 4. You can add objects inside, and then inside them, you can have nested arrays, and you can have arrays within arrays within arrays. You get inceptive, okay? All right, but hopefully you get the idea. So how do we set proposals for many arrays? So what we want to do is now access our proposal and use it as we would use an integer, as we would use a Boolean. We want to use these as a data type that we can declare. So if we create an array for proposals, and we say, hey, we want this new proposals things to be an array, but we want it to carry the information of proposal, we can just write proposal as an array, so store our proposals of proposals. And now the final thing that we want to alert Solidity, or let's declare for Solidity, is that we want our proposals to be publicly accessible. And what does that mean? Well, that means that we want our proposals to be accessible when we're deploying our contract. We want access to our proposal outside of our contract, and we're going to see this afterwards. Why? Because this is information that we're going to be interacting with, and we don't want to keep it just in our contract. We want this to be information that other people can access, other contracts can access. So we do that in Solidity by typing in public. It's as easy as that. And just like that, we've now created our proposals that carry our own structured data type with name and a vote count, and can set it into an array. So congratulations for creating that. That's pretty awesome. And the final thing, don't forget, and our expression. This is another expression. All right, so we created a place for our proposals. Now we need to do the same thing for our voters too, right? We're going to have multiple voters. Each voter is going to have their own address, and we're going to want to keep track of these voters with their address. So a great way to actually do this is with the mapping method. So mapping Oops, no 3 Ps. So what mapping does in Solidity, mapping allows for us to create a store value with keys and indexes to keep track of, all right? Just like in JavaScript, when you map through something, you iterate through something, but you also create an index, or you create this dictionary where you can keep track of each thing, and then you can actually allocate each thing. You can give each thing a number, a piece of information. What we want to do with our vote is, when we map through, is that we want to have addresses, and each address for our voters. For our voters over here is information that we want to keep track of. And we can do that by using mapping. So how do we do this? Well, it's similar to proposals. Basically, we want a place for our voters. And we're going to go bring in mapping. And then mapping is a method. So we're actually calling mapping. And then we're bringing in the arguments. And what we can say inside is we can say address. And inside our address is where we can actually say, well, we want the voter to get the address. So each voter will have an address. So if we bring in our struct voter, now our voters are going to each get an address with the information, and we can keep track of all of it. That's what mapping does. That's the importance of mapping. And if that doesn't make any sense yet, or doesn't make very much sense, don't worry, because we're gonna actually see it when we're gonna actually see it work when later on, when we loop through the map, where we're going to be looping through our voters. We're going to be creating a loop and iterating through. So for now, if you don't understand that, at least get the takeaway that what we did was very similar here, where we bring in our struct voter, okay, and we're using that to create our voters, okay, so voters, and we're creating a place with mapping to keep track of our voters. And the final thing here, if you can guess what the final thing to do, well, we also want our voters to be accessible outside of the contract, so we make it public. So voters get the address as a key and voter for value, right? You get a key and a value when you're mapping. So the address is the key, and the voter is going to be the value. So we'll see this later on in a bit. Okay, so we have our mapping now. We've created our structures. What else do we need to have before we start building out our contract functionality? Well, if we scroll back up, we see that we have the proposals done, the voting. Well, this chairman, right? Or let's just say chairperson. Maybe it's a chairwoman. I don't know. Or chair binary. So just chairperson. So we want to create a chairperson. So how do we do that? Well, to create a chairperson, we're going to keep it simple. We're just going to have an address, and we're going to make the address the address is going to essentially be the main address of the chairperson. That's the person who's deploying the contract. That's the person that's going over everything, making sure things are working. So what we want to do is just create an address for now. We're going to make it public, and we're going to assign that to chairperson. Okay, and just like that, now we have also instantiated a chairperson to the contract. Wonderful. All right, so next up, we're going to bring in a special function. All right, the special function is called a constructor. All right, and the constructor here acts like a function, right, where we bring in our argument and we bring in our curly brackets to indicate that the data script inside that goes inside the function. All right, but what's great about this constructor function in Solidity, it has different use cases and different frameworks and languages. But in Solidity, what the constructor is going to do is that when we deploy the contract, it's going to run the code in the constructor to deploy immediately. All right, and this is really important because what we want to say is that the second we execute this contract, we want the proposal. We want to add our proposal names, right? We want to say that right away when we deploy this contract, we are running the contract because we have proposals, right? This contract is only happening because there are proposals to begin with. Otherwise, we wouldn't be wasting our money and wasting our time doing this. So there are proposals. People are undecided, so we're going to run a vote, and the vote's going to call the smart contract with the proposals. That's why we're going to put it all in the constructor. So hopefully that makes a bit of sense. If not, no worries. We're going to write this constructor out now together and then deploy a test version to see that it actually, to see that we haven't made any mistakes so far and that we can actually deploy, and that we can actually deploy with proposals when we start. So what we want to do is we write constructor, as we've done with the curly brackets. Now for the argument in our constructor, what do we want to take? Well, we want to create an argument in our constructor, all right? And we want this argument to essentially be where our proposal names go. So the input for our proposal names. So how do we do that? Well, we can just write proposal name. We're going to call it proposal names, all right? And proposal names is going to be what? Well, the proposal names, if you remember, we're storing them as bytes instead of strings. So we're going to do the same thing here, right? Bytes 32. And we're also going to add one other tag here to proposal names, and that's going to be memory. All right. So what is this what is this weird memory thing that we're looking at? Well, memory, what it does is it allows for proposal names to be temporarily stored. Inherently, okay, when we declare bools, when we declare data types, we are sending everything into storage. And when we send things into storage, they're going to last there between function calls, okay? But when we set something to memory, it is more temporary. Well, essentially, memory defines a temporary data location in Solidity during runtime only, okay? So this memory is only stored during the runtime, whereas if we used storage, if we explicitly declared this to be in storage, then this function would, then proposal names would not be wiped off. But with memory, we wipe it off. Now, why is that important? Well, again, this creates for more efficient code, right? Because proposal names, we don't need proposal names to be in storage. We want to keep it temporarily. We guarantee that space, you know, right? We guarantee space for it. Whereas if we don't use memory, then we may get unexpected results with our storage as well, okay? And we can say during runtime only of methods, right? We can only call this this only happens in our methods. So we're going to do that. We're going to add that. Now, this is a little bit tricky to get your head around at first, so don't worry if you're not 100% sure about memory versus storage, but I'll provide a link where you can check out more if you want to read more about memory versus storage in Solidity. But we're going to bring in memory for our proposal names, and now that we have that as our argument, what do we want to add here? Well, what we're going to do is we're going to add a for loop. We're going to write a for loop together. Now, what is a for loop? Well, a for loop, you bring it in by typing in for, okay, and then you add the arguments inside. And for loops essentially allow us to run loops. And why do we want to run a loop? Well, because we want to iterate or loop through our proposals, right? Because we have multiple proposals, and what we want to do is when we deploy this contract, we're going to have our proposal names, and then we want to loop through each name in the proposal and have that information ready for our voters, right? Now, if that doesn't make sense, just bear with me because we're going to see this work together. But firstly, let's actually look at how do we even write a for loop. So to write a for loop, what you want to do is you want to have there are three parts that we need to consider, and it's always the same pattern, so if it looks a little bit weird at first, you get used to it. So the first thing is that we want to set up an index. That's our I, and we're going to set it to 0 in this case. So we're going to start at 0. So uint I equals 0. Then the first parameter here, is initializing I, all right? The second one is how long do we want this for loop to run for? How long do we want it to run for? Well, we want it to run through all of the proposal names, right? So then we can say I, because that's what's running through each one, should be less than proposal names dot length, okay? And so dot length basically the completion of all the proposal names. It's going to go through each one till the end. So we want I, this is the second thing we want the loop to do. We want it to run through all of this. So the first one we initialize, I'm going to say run through, and then after we run through each one, we do I++ like that. Okay? And the plus just means that we're adding one after. Plus just means that we're adding one after I. It's a syntax that you also get used to working with in a for loop. And without getting more deep into it, let's just leave it at that and not get too controversial here. Okay, and now that we've created this loop, we can actually bring in these curly brackets and direct the loop to do something. So while it's looping, while we do this loop, or as it's looping, or after it's looping, we can set the conditions, and this is where the real power comes in. So why is this important, and why did we create this loop? So hopefully now this is going to make sense, because remember, we created an empty array. What does that mean? It means that we have a proposal. We have our proposals set up as an empty array, meaning that there's no proposals yet. It's just a space where we can put our proposals, and we want to loop through these proposals, but there's no proposals yet to loop through, right? But we want to loop through the names of our argument that we're going to be adding. So we're going to be adding names, then we want to loop through each name and actually add them to the empty array, right? And add them to the empty array, right? So that's why we're doing this, so that we can add them one at a time into our proposals, and that way after we deploy the contract, our voters can get access to each one. So it sounded like a mouthful, but it's really not complicated. It's just adding them. It's just adding each proposal name into the array. So hopefully that makes sense in the way I explained it. But in any case, we're going to see this in action. So don't worry if you're still not sure. So what we want to do here is we want to say proposals. Right? We want to access this array, and we're going to use a method. We're going to push, and what push does is it pushes each name into the proposal. Right? When we use .push, then we add things to the array. So .push allows us to add, and what do we want to add? We want to update our proposal information right over here. So how do we do that? Well, we just bring in proposal, and then within proposal here, we can add in the curly bracket the object of information from our struct. Where is it? Here, right? By adding in this curly bracket, we actually have access to our string, or our bytes of the name, and the vote count. And here we can say, well, what do we want to push? What do we want to be adding? Well, we can access both. We can say, well, we want the name, so we can type in name. And what do we want the name to be? Well, proposal names at the index of I. So for each name that we're iterating over that we've added, we want to update this name property. So we're adding the name, right? And then we bring a comma because we also want to, what's the other one we want to do here? We also want to update the vote count, right? So we're going to do vote count. And since there's no votes actually happening, all we need to do really here is just initialize the vote count. Oops. Sorry. We just need to initialize this vote count, and we just do that by typing in 0. It's just as simple as that. So we bring in 0, and like that, we actually initialize the vote count because we don't want any votes yet, right? That'd be cheating if we wanted to somehow manipulate this code and say, well, always give 120 vote counts to one specific thing. No. We want everything to start a clean slate at 0. And then it's up to the voters to decide, right? We're making this community about governance, and it's great, and we're using decentralization, and we're upholding these great values in our code. Okay, awesome. So this essentially will add the proposal names to the smart contract upon deployment. Okay. Is there anything else that we want to add to this constructor for when we deploy this contract? Anything else? Well, there's two other things I would want to add. The first thing here is that we want this chairperson to be acting as a verification, authentication process for our contract. We want the chairperson to be the person who's effectively calling this contract. We want to assign them to the message sender. So only the chairperson can have that access to do that. We don't want everyone to have that access. And how do we do that? Well, what we can do is we can leverage a global variable called message.sender. And message.sender is a global variable in Solidity. And what does it do? Well, it's a global variable that states the person, all right, who is currently connecting to the contract. Okay, so we want the chairman to be that person who is currently connecting to the contract upon deployment. We set that up. We're going to set this up so that way when we want to check afterwards who has the access, who has the right to vote, who doesn't have the right to vote, who should be deploying this contract, we're always considering that it's just the chairperson can do that, because otherwise we don't want anybody to be able to just go in and do what they want. So how do we write that code? Well, it's very easy. We just say chairperson is going to equal message.sender, and we close our expression. All right. And do I need to close? I'm looking right now. I think this for loop should also be closed. So we should add also an expression to close the loop as well. I just noticed that over here. So I added a semicolon over there as well. All right. So we have our chairperson as message sender. All right. And is there anything else? Well, let's actually give our chairperson a weight of 1, when they deploy. Well, we're going to add to our voters the chairperson. Okay. Oh, chairperson. All right, let me make that a little bigger. And here, let's actually comment in, add 1 to chairperson weight. All right, voters, chairperson, and we're going to access the weight, right? Because now we are essentially allocating the voter information to chairperson, and we're going to set this to 1 already. Don't worry if this line of code is a bit confusing right now. Once we write out the voting functionality, we'll come back to this and make more sense of it. All right. So, but for now, what we're going to do is we're going to add a level of weight to our chairperson. And so now the key thing, though, is that if we compile this code down at its current point where we are right now, then we should be able to at least successfully compile, deploy, and add names, add proposal names, albeit in byte format, for our proposals. So why don't we give that a shot? So what we're going to do now at this point is I'm going to go ahead and hit Command S to save. As if this were a text editor, you can actually save and run through the code to debug to see if we made any mistakes. So I'm going to open up the console because I probably made some mistakes. I was going through all this pretty quickly. So let me get this console up. So I can push up the console. You saw I did with my mouse. And then I scroll down to where we see this arrow at the bottom here. I'm going to hit save and see if we have any errors. Huh. All right. So I don't notice any errors. We're going to switch to, I don't notice any errors in the console, but we're going to switch to our compiler, Solidity. And I'm going to scroll down here and I see a parse error. Parse error, found version pragma but failed to parse it. Please ensure that there is a trailing semicolon. Let me go up. So I made an error right away at the top. There I was gloating about how I made no errors. And right away in the first line, I've got an error. So I did not end the expression. So we're going to save, added a semicolon. And now that I'm doing that, we're actually running through the code and we're going to find more errors. So let's see what else is happening here. Line 56, expected a comma, but got semicolon. Okay, so my mistake here is that we are in object format under name and vote count in our for loop. And we can't be using expressions. We're not ending expressions here. This isn't the end of an expression. We ended the expression after over here. This is where the expression ends. This is actually still part of the expression. So it'd be like putting a period in the middle of a sentence. Or it would be like using a period as a comma. So I'm just going to get rid of that semicolon and save. And data look. Okay, and we've got this SPDX license warning, which is fine. Don't worry about that. Data location can only be specified for array struct, but memory was given. All right, so it doesn't like that we're using memory over here. Let's take a look. Okay, so the mistake here is that proposal names, as I can see over here, we created this argument proposal names. We set it to memory. Now, this isn't one name at a time, right? This is proposal names. Proposal names should be an array. If we leave it like this, we're actually making it just a string, all right? We're making it just byte form or just a data type for our strings, right? proposal names.length here, what we want it to be is an array, right? So bytes32 should actually be holding an array, and we can just do that by bringing an array over here. Let's save. And by saving, by saving it again, it looks like we've actually completed all of our errors. We have no more errors left. Awesome. Okay, so now that we've gone through fixing all our parse errors, let's go ahead and click on the compile ballot vote. And we do that over here, and this is going to compile our contract down. So we do that there on the second tab, or the second tab down from the alien head. So we compile it. We'll see a compiler. They're modifying JSON for me, which is because I was already playing with this contract beforehand and practicing it before, doing it together, doing it in video, so that I don't confuse myself. All right, how do I make this console smaller now? Where is the thing? Hold on. Oh, there it is. Let's bring this console down for now. All right, so we've compiled it. Now we can deploy it. So we're going to go down to deploy. Now, when we deploy, let's make sure we're on the first account, because this is going to be the account of the chairperson. And all these other accounts are going to be for our voters. All right. So let's say we've got 10 people in our community. We got one chairperson and then a bunch of people that like to vote. So what we want to do is, if you look under contract, you should see your contract popping up, ballot. And we should see an option to deploy it. This deploy is from our constructor. It's essentially the constructor function, is the deploying. That's what's going to deploy, or meaning that it'll deploy even without the constructor function, but we want to add these proposal names as we deploy, and we have that access now with the constructor. If you notice, we now see proposal names next to deploy. All right. So if I created an empty array, then I hit deploy, what do you think would happen? Well, we would be deploying our contract, but with no proposals at all, right? So if inside our array we add bytes, and bytes would be, they're written like in these very long formats over here as strings, which we're going to do later on, then each one will represent a proposal name. For now, just to see that it works, just to see that all the work we've done up to this point is good, we're just going to deploy an empty array and test if this is working. So let's click on deploy. And would you look at that? If you look at the bottom under deployed contracts, you should see your ballot deployed. Ballot at 0xd91 ... That's our smart contract address. We're going to take a look more. We're going to take more of a look at that later on. But there it is. And if I scroll down, we actually see our proposals, our votes, and chairperson. So we got some functionality in here. We've got some information in here, and we see our address. So we have successfully created a smart contract. Now, it doesn't do anything except for input bytes of proposal names, which we don't know how to do yet. But we're going to take a look at that at the end, I think. I could do it now, but I think it's better to wait. Let's just wait to do that afterwards. So just congratulations for getting this far. Even if you got this far and you're just starting to get your head around smart contracts, we've covered quite a bit up to this point. So great work making it this far. As we continue moving forward now, we can move on to the actual functionality of our smart contract. So the next thing that we're going to be working on is going to be the authentication for our voting, as well as the voting itself. And then we are done with our smart contract. So if you want to pause the video and make a coffee and take a break, you deserve it. If not, let's keep on going. We're going to want to have a function for voting, right? So we can make a function for voting. We're going to want to also make a function to authenticate votes, right? Authenticate votes, give access to votes. And then we're going to want to have some functions to actually show the results, right? So functions for showing the results. All right, results, right? So that should make sense, right? We want to bring in the proposals. Then we want to authenticate our voters. So maybe authenticate voters. Here, let me make this bigger so you can see. Okay, so hopefully you can see that better. So function authenticate the voter. We need a function for voting and functions for showing the results. Okay, we're going to make two functions for that. So why don't we do the authentication one first? So we're going to make a function and we're going to call it give right to vote. Okay. And this is going to be public. And we're going to have an argument that essentially is going to be for the voters, because we want to give the right to vote of what? Of an address, and the address of each what? Voter, right? So we're going to have an address voter. So this function essentially is going to take this argument where we put in an address, and then the chairman or the chairperson is going to be the one who puts in the address. Only the chairperson can put in the address. And then as long as they haven't already voted and they pass off our requirements, then they can vote. All right. So this gives the right to vote, and this kind of watches for a community, right? It takes care of the community. So what should we do? So let's do the requirement for the chairman. So we can actually do that by bringing in this method require. And when we bring in require in Solidity, this actually allows us to basically say to Solidity, well, only let this function continue to run if it meets this requirement. If it doesn't meet the requirement, then pass the following message. Stop running it and pass the following message. So it's kind of like an error. And so what do we want to require? So the first thing I want to do is say the chairperson should equal, or sorry, not the chairperson should equal, but the chairperson should be equivalent to the two equal signs. What? Well, message.sender, right? But actually, we probably want this the other way around, right? We want the message.sender, to be equivalent to the chairperson. This makes more sense, right? Because we want the person that's calling the contract, the person that's calling, sorry, not the contract, but calling the function give right to vote has to be, it's going to be the message sender, right? And who is the message sender, the person calling it? Well, then that's going to have to be the chairperson. And this is essentially our argument. So we can say this, and then for the second part of our argument, after we create the assertion here, we can say, well, our message. So we can say only the chairperson. Only the chairperson can give access to vote. All right. And let's not forget to finish the expression, right? So what's another requirement? Well, let's add another requirement. Well, we also want a requirement that's going to say that require that they haven't voted yet, right? That the voter hasn't voted yet. So we can actually do that with the with our voted Boolean over here. So how would we write this? Well, what we could say, we would want to go into our voters and our mapping, right? So we have our voters over here. We want to go through the voters, and the voters of what? Well, the voters of this address. So the voters of the current voter dot what? Dot voted. And this would have to require that they have voted. So in order to say, well, let's require that they haven't voted, well, we could write a whole if condition, but instead of doing that, why not just turn this true to false by adding a bang? So by adding this bang, we turn the statement to false. We say that the voter of the voters in our mapping, the voter with the address, okay, dot voted is false. They haven't voted yet. This without the exclamation would be true. We add the exclamation, it's now false. Okay. And what's our message in case it doesn't run? In case that they have actually voted? Well, we have to indicate, well, we should indicate that they've already voted. So the voter has already voted. Okay. Not the best English, but you know, it's not the best phrasing for that, but it gets the message across. We're at another semicolon. All right. And so we're doing that, and so we're requiring that they haven't voted by voted. We can also check the same thing that they haven't voted by wait, right? We can check it with wait. We can say that, like we said in the beginning, we can say that if their wait is 0, it means they haven't voted yet, okay? So we can make another requirement. Don't worry, it's a little tricky. Well, it's going to be very similar to this, right? We want to access the voters. We want the voter. But instead of voted, we want the wait, right? And what we want is we want the wait to equal 0, right? Or sorry, we want the wait to be equivalent to 0. All right. So now that it's equivalent to 0, it means that they haven't voted yet. But what do we actually want this function to do? We want to give the right to vote. This is requiring so that we can give the right to vote. That's what these did, but we haven't actually given the right to vote. So how do we actually add that functionality? Well, it goes with the weight again, right? We want to actually change the weight of the voter of the voters. So we do that by taking this statement, voters, voter.weight, but we actually want to change the value of the weight. We want to add 1. We can hit save. Save and make sure we're not running into any other errors here. So let's check our compiler. Good. No errors so far. Awesome. And that's it for the function for give right to vote, right? We're making sure that only the chairperson can do this. We're making sure that the voter hasn't already voted. And then we're actually giving them the right to vote by adding 1 to the weight. So the weight is not that whether or not they voted, right? The weight is basically showcasing their ability to vote, the ability of to vote, and the ability to what extent. Using it in a numerical way like this is much more scalable for the code. All right, so let's now actually build out the function for voting. So we should just call this function vote, right? And what are we voting on? Well, it's a proposal. So we're going to do one proposal. We're going to make it public, right? Because we're going to be accessing this. We're going to be making votes. And essentially what we're going to do is focus on each person sending a vote. So we're going to call them sender, and we're going to set up to our sender the properties of our voter. All right, so we're going to say voter sender equals voters of our message.sender. And we're actually going to set our voter to storage. So whereas memory was temporary, right? We were defining a temporary data location. Here we are defining a data location that actually will run between function calls as well. So what does this line of code actually mean? Well, we're creating a variable sender with the data type properties of voters. So voters here. Oops, sorry, that's a mistake. It should be voter, not voters. Sorry. We want the data types from the voter. Okay, so we're setting that up to our sender. And we're making this equal to what? Well, sender is going to be of our voters. All right. And that's our voters that are being mapped out of the person calling the contract, the sender. All right. And so let's build up some requirements. So what do we want to require? Well, we want to make sure that in order for them to vote, they can't have a weight of 0, right? When we give them the right to vote, we give them a weight of 1. That gives them the right. So we want to make sure that the weight is 1, right? We did that in the give right to vote. Do not get confused by the weight and the voted, right? These are different. This is the weight, which is checking in. So we're using this for vote, and voted is to check whether or not they voted. So we can say sender.weight should not equal 0, right? If it does equal 0, then we can add the message has no right to vote. What if they've already voted? So let's do a requirement, sender.voted. Okay, so this should make sense. Sender.voted, if this is true, if the sender.voted is true, if they've already voted, then they've already voted. We're requiring the sender has voted. But what we want to do is we want to require that the sender hasn't voted. So we put that bang. So this just says if the sender hasn't voted, so what this really says is if the sender has voted, then display that they've already voted. Stop this code. Don't do the vote. If they haven't voted, if sender.voted is false, then just continue on with the code. Don't give this message and you can continue with the vote, right? We haven't actually gone into the vote yet. Let's do the vote right now. So how would we actually change the property for our vote? How would we actually make the vote happen? What we want to do is sender.voted is going to be true now, right? Right? Because we want to switch our status here of our Boolean of voted to true because they just voted. So we have to update the status. Okay. What else do we need? Well, remember, when they vote, they're voting for the proposal. all right, this argument. So we want to send that proposal to the vote. So we can say sender.vote is going to be the proposal. So remember, vote is not a Boolean, vote is an integer. This is going to keep track of each proposal. And we set up proposal to be an integer here as well. And that's why we set up the vote as an integer. It helps us keep track. So now we can say the voted is true and the vote is set up as a proposal. So let's save that, make sure I'm not making too many mistakes. We see a mistake over here. Undeclared identifier, did you mean sender? Oh, yes. So line 81 should be sender, not send. Let's fix that. Okay, awesome. So finally, how do we add to our proposals the vote count, right? Because we want to accumulate the votes now into our proposal. And we can do this in our vote function as well. So how would we build this out? Well, we want the vote count, right? So what we can do is we can say from our proposals, grab it that way, and specifically we want this proposal from our argument, and now we can access from this one our vote count. And what do we want to make this equal to? Well, we want it to be equal to the same thing, right? The proposals of the vote count, whatever we had previously, which would be 0, plus what? Well, we want it to be plus the sender.weight, right? So the sender.weight is the weight of the vote. And if somebody is voted for, if somebody has that weight to give a vote count for 1, then their weight of the vote counts as 1. And therefore, what we can do is we can just use the sender weight to add to the proposals in order to keep track of the in order to keep track of the vote count, right? Now it's a little bit tricky, but hopefully you're getting it. Let's look over this function again. Basically, we create a function vote. We take this argument as a proposal, all right? That's going to be the proposal, and we take it as an integer, all right? We set it to public. We make a variable called sender. Sender takes all the voting data structure, all the voting data types, right? And then we say that their sender is going to have to be equal to, from our voters, establishing the message sender. So it's going to be the person calling this vote. Whoever is voting is going to be the message sender, the person who's calling the vote. So after we've established that, now we can actually do some things with our sender here. We can require that the sender's weight isn't 0. If the sender's weight is 0, then they have no right to vote, right? Because we give them a weight of 1 in order to vote here in the give right to vote. And over here, we actually say, hey, wait a minute, you can't vote if your weight is at 0, right? So this is a very good security measure. What else? Well, we require that the sender hasn't voted yet. If they've already voted, so then they shouldn't vote, right? That wouldn't be fair. So we do if sender require that the sender.voted hasn't happened. If it has happened, then say already voted. All right. Sender.voted. Okay. So after our requirements, we run what we want this function to do. We want to update the status of voted to true because they've already voted. And then we want to set the integer of the vote to the proposal, right? If they vote for the first proposal, then that sender vote's going to be 1. If they vote for the second, that's number 2. And that's actually what's going to keep track of our index of the vote, right? Here, vote index, up here. Now, what about the actual vote count? How do we keep track of how many votes are happening? How do we accumulate these votes? Well, what we do is we go to the vote count in the proposals. We set it to the proposal over here, okay? And then we add it to the sender.weight, right? Because if the sender weight is 1, then that's going to be the vote for 1. Another way to write this would be just plus equal, right? It's the same thing. It's the same thing. All right, so great work coming this far. We're getting very close now. We've got the give right to vote function. We've got a vote function, so we have our functionality built out. We have our deployment for our constructor to set up our proposals. And we have our data types, so everything's working. The final things we need to add to make this work on our smart contract is going to be ways to actually show the results, right? We want to see who won. We want to be able to display this information. So we're going to create two functions to do that. We're going to do one function that shows the winning proposal by integer, right? Because that's how we're keeping track, by integer. So it'll show you 1. If it's 1, if the winner is 1, then that was the first one we put in. If it's 3, then that was the third proposal, etc. So a function that shows the winning proposal by integer, okay? And then a function that shows the winner by the name. So the name of the proposal. So we're going to have two functions, one that does that and one that does that. So let's build out this function first. So we want to do function winning proposal. All right. And we're going to want to make it public. We're going to add view, so that view just means we can't change what's happening inside of this. So we can just view it, right? So word view. And we want it to return something specific. So we're actually going to write, in order to do that in Solidity, we're going to bring in the returns value here. It's a little bit weird. It's a little bit strange if you're used to just JavaScript. Well, we want to return which number is the winner, right? The integer, the winning proposal by integer. So we can do that by creating an integer, and we're going to call it just winning proposal again, but we'll add an underscore so we can differentiate and not get confused. Okay, and now we bring in our curly brackets for our function. Now, what do we want to write for our winning proposal? How can we actually display these results? Well, we want to make a vote count. So essentially what we want to do is go through all the proposals, right, where we're keeping track of all our proposals, and then find out which one has the most, the highest vote count, and then display that. That's essentially what we want to do. In order to do that, we're going to have to make a loop. But before we loop through, we're going to have to create a variable that can store this information. So we can say uint winning vote count, and we're going to set it. We're going to initialize it at 0, right? We want to start at 0, and then we're going to add. Okay. Now we're going to make a for loop, and we're going to be looping through these proposals, right? Through all of our proposals. So we can say for uint, just like we did last time, I start at 0. I should be less than proposals dot length. I'm going to go for the full distance. I plus plus. All right, so this is our loop. Very similar to our other loop that we made for our proposals when we were bringing in the proposals. Now we're creating a second loop to actually go through the proposals and add up the vote count. And what we're going to do is create an if statement. We're going to say if the proposals of our index I is greater than the winning vote count, then the winning vote count is going to equal proposals of I dot vote count. And okay, and so what are we saying here exactly? Well, we're saying that then we set our winning vote count to equal the proposals I dot vote count. So if we're getting something in our proposals, then we add that to the winning vote count, okay? And that's how we're adding to our winning vote count. But how do we determine which one is the winner? Well, we can say winning proposal, this, right? What we want to return here should actually be equal to that index of I. I is going to be telling us which proposal is the winner. And that's what we want, right? We want to find the winning proposal. All right, so we want to also have a function that could actually spit back the winner, right? We have the winning proposal. We want the winning name. So we're going to make a function. We're going to call it winning name. All right. And it's going to be quite similar to our winning proposal, right? Because we want it to be accessible and we only want to be able to view it. And we also want it to return the winning name. So we're going to do the same thing where we want a winning name but an underscore, right, to differentiate. And winning name, though, we don't want an integer. We want the name, right? So we would usually say string, but because we're saving on our string transactions, we're going with bytes. And we're going to go bytes 32. Okay, excellent. So what's the logic inside of our winning name? What do we want to do here? Well, we actually already created a winning proposal to find out which one is the winning proposal. We have this function. And in fact, the function, even though the function just returns for us and for the function, the winning proposal, which one it is by number, we can see that we access the winning proposal, information through the proposals. So if we wanted to actually get the vote count, so if we wanted to actually get the name from our winning proposals, well, we could actually go to our proposals, and from our proposals, actually grab the winning proposal, and inside the winning proposal, and grab what from, and what should we grab from our winning proposals in our proposals? Well, what do we want? Well, we want the name, right? And we can just get it with dot notation. And we can set now, all we have to do is just set this to our argument. So winning name should be equal to the proposals winning name should be equal to what? Well, it should be equal to our winning proposal name in our proposals array. And let's not forget to end the expression. Let's go ahead and save and see and check out on any errors we have. Okay, so we see that we have an error here. Operator greater than not compatible with type struct ballot proposal, line 95. Well, we want to grab the vote count from our proposals, right? We don't just want to grab from proposals sorry, I made a mistake here. This should be I.vote count. So let's go ahead and fix that and save. Okay, and we see that, and after we fix that, we should see our errors go away, except for the warning. And remember, why is it the vote count? Well, because, let's do a review of this for loop one more time. Well, we create a loop, and we're looping through all the proposals, and then we check the vote count of our proposal, and we say if the proposal's vote count of the index for where we're looping is greater than what the winning vote count is, then we're going to do two things here. We're going to set the winning vote count to equal that vote count, the proposal's vote count, so this should have been the same. And then we want to set the winning proposal to I. And that's how we return what the winning proposal actually is as an integer, because I will give us the index of the integer of where it is. So if that's a little confusing, don't worry. Let's go ahead and actually deploy this contract and go through the loop together to see if it's actually working and how it's working. All right? Because guess what? We are effectively finished. We've done it. Finished. That's it. This is our smart contract. We are done. We've completed everything we needed to create our smart contract. We have our ballot. We've created our contract. We called it ballot. We built in our data types. We set up our proposals. We set up our voters. We set up our deployment for our proposal names. And we've added functionality to add the proposals. And then we've added functions to give right to the vote, functions for voting, and then functions to see the results. Let me just get rid of this index. And now we are ready to deploy. So what we want to do is the same thing that we did before. We can rerun a compile, so we can hit compile ballot. Then we want to go back to our deploy and run transactions. Make sure we don't have any contracts already deployed. So if you have anything deployed, just delete it with the trash button or an X. Okay. Now we want to make sure that we're in our JavaScript VM, all right, virtual machine. We have our 10 Ether accounts. We're going to use the first one as the chairperson and the other ones for transactions. And now we want to deploy our ballot contract. But hold on a second. We can't just do a regular deployment for our ballot contract, right? Because remember, if this was in strings, remember that we set everything up in bytes to save gas transactions. If this was in strings, all we would have to do to deploy it is make an array and then add quotations for each string and say each name. So we can say, let's say we're voting on whether we want a coffee machine in the office or if we want office supplies. So we would say coffee machine, comma, other quotations, office supplies. And then this could be something that we'd be voting on. But if we try to deploy this like this as in string format and we click on deploy, if we check our console, let me open up the console, we're going to see here creation of ballot errored. There's an error encoding arguments, error invalid array, arrayify value. All right, so value coffee machine, it's an invalid argument. It doesn't understand this format. So how do we get over this hurdle? Well, if you remember from the beginning of this code along, you download node.js and we would write the script together to convert it, or I'll show you another way to do it after. So if you do have Node in your terminal, then you can continue to code along. If you don't, I still encourage you to keep on watching anyway until the end, because we're still going to go over a few important things, even if you can't code along up until the end. Okay, so how do we actually convert our bytes? How do we actually convert these strings into bytes so we can deploy this contract? What do we do? Well, the first thing we want to do is bring in our terminal. And let's just make it a little bit larger so you can see it. Okay, so I'm going to cd into the desktop. So I'm going to move into the desktop directory. And in my desktop, or in some kind of folder where you feel comfortable, we're going to make a new directory. All right, and I'm going to call this transform. Now we're going to make 2 new files in our transform directory. But first we need to cd into it. So I'm going to go into transform. Now in here, we're going to create 2 new files. So I'm going to bring in touch. One's going to be called parse bytes, and they're going to be JavaScript files, .js, and then create bytes. Okay, so create bytes is essentially going to convert our bytes. Create bytes is essentially going to convert our strings into bytes, and then that's what we need to deploy the contract. And parse bytes is going to convert our bytes back into strings, and that's going to show us the winner of our vote. So we're going to do that. Now if I list, we should see create bytes, parse bytes. All right. After this, I want to initialize npm. So I'm going to do npm init -- flag just y for yes. And by doing the -- flag, we don't have to go through everything such as name versions. We're just going to automatically say yes for everything. Okay, make sure that you can still see that at the bottom. Can you see that? Hold on, let me just fix this. That's better, right? Yeah, you can see that. Okay. Okay, awesome. All right, so now that we have initialized our npm, we can actually install some packages. And if you're not familiar with npm, npm essentially is a node package manager which allows you to install libraries. We're going to bring in a library called Ethers. So what is Ethers? Well, Ethers is the complete Ethereum wallet implementation and utilities in JavaScript and in TypeScript as well. It's a really great package module which gives us a lot of different things that we can do in working with Ethereum. And actually, if we go to the documentation, so getting started ethers.js, and if we go to the docs and we type in format bytes here, we see that we have a parse bytes 32 strings, which can return the decoded string represented by the bytes. And this can actually transform our bytes for us. So we're going to bring this in just so that we can do this conversion. Maybe it's slight overkill, but it's going to get the job done. So we're going to go here, terminal, that. And it's okay if you're not sure what that means. I'm going to show you in a second. So right now, back on our terminal, we see we have these 2 files. We have, or 3 files. We have the create bytes JavaScript, the package JSON, and the parse bytes. We want to open all these files in our text editor. So I'm going to do code dot for Visual Studio Code, and it's going to open it up. Or if you want, you can just open up these files in your own text editor, whatever you're using. Sublime, that's just a shortcut for me to open it. All right, and now we see that we have in our transform folder directory our 3 files, create bytes and our package JSON. Now, back in our terminal, we want to add as well. So back in our terminal, we still want to add our Ethers libraries. How do we do that? We can just do npm I or npm install Ethers. Once we've installed it, you're going to see that we may have a couple warnings. It's fine. You don't have to worry about those. But we'll see that we've added the 44 packages and we have it successfully installed. So now if we go back to our Visual Studio Code and we check our dependencies in our package JSON, we're going to see Ethers automatically added. All right, so that's great. That means that now we can access. That's great because now that means we can access our Ethers. Well, in our createbytes.js, what we can do, we can access it by bringing it in. So we can create a new variable in JavaScript. We do that using const, creating a constant variable in JavaScript. So we do const Ethers, and we can set this to require, and we want to require Ethers. So we can do that. And what we're going to do is we're going to create an async function We're going to call it create bytes, and this is going to be our function which converts for us our bytes. Okay, so we have an async function create bytes, and it's going to take an argument, so we'll just call it args. And now we're going to want to have it convert into something, so we're going to call that the name, right? Because we want to get names. So constant name, we're going to set it up as an array that takes integer value of 0 to start. Okay, so we're going to initialize our name at 0, and now we're going to make another variable called bytes, and we're going to grab from ethers or utils. And from our utilities, we can actually scroll, you'll see format bytes 32 string. And this is essentially what's going to do the conversion for us. And what do we want to convert? Well, the name, right? So we can run this to the name. And let me just zoom out so you can see that a bit better. Okay. And then finally, after we have the conversion, what do we want to do? Well, we actually want to show what these bytes are converted, right? So we can just do that on our terminal with a console log, and we'll just say bytes like this and say name. Or we can just do it like this even. I'm going to do it the other way around. Let's do it like that. Get rid of the comma, right? All right, so we're going to console.log our name. And then we want to actually call the function. So we want to say create bytes. And when we call the function, we actually want to slice. Then we actually want to slice so we get the right bytes. So slice it. And we can do that by actually bringing in argv dot process dot slice. And we're going to slice 2. Okay, so we'll save that. And finally, we actually want to add our argument to the name, right? Because the name is going to be the argument that we put in for this function. That's what it's going to be assuming the name is. And so we can actually add the argument to our value here like this. And that's going to actually hook up the argument to the name. Okay. And actually, we don't get arg from process. I think I just realized I did this the wrong way around. We want to grab from our create bytes process first, then arg the dot slice. Okay. And so this is the code in all its glory in order to convert our name into byte format, to convert our proposal names into byte format so that we can run our vote and see if it works or not. So let's just go over what we did one more time. So we created a variable called ethers, and we set it to our library of ethers so we can access it. Then we create an async function, so a function that's going to wait, and we call it create bytes, all right? Because that's what, call it create bytes. And now it takes an argument, and that argument is going to be the name. And that name, of course, is going to be converted into this, converted into the byte format, so we bring in the array with a 0. Now we create another variable called bytes. And bytes essentially is bytes essentially is going to be what does the conversion for us of the name. So we grab into our library ethers from our constant utilities to get to our format bytes 32 string, which converts the name for us. And then finally, we console.log the name in bytes. So now if we actually go back into our terminal, we can actually run this script and do conversions for us. So let's say we want to convert coffee machine into bytes. All we have to do is type in node and then access our script, create bytes.js, and then put in the argument that we want. So it's going to be coffee machine, right? So if we do that and we hit enter, we're going to get the name converted. See, we have our name here, and there it is. That is our conversion. Amazing. All right. You have successfully utilized Node to create a code that can do conversions for us. That's pretty awesome. All right. So now that we went through this one together, go ahead as an exercise, pause the video, and try to write the code for the parse bytes. Remember, the create bytes, we're taking a name and we're turning it into bytes. For the parse bytes, we want to take bytes and turn it into a name. So very similar, but not the same. So go ahead and give that your best shot. All right, so hopefully you had some success. Let's give this a shot together. So what we want to do is we're just going to copy everything from our create bytes, post it into our parse bytes, And we're going to change the function name to parse bytes, of course. If I can spell it, bytes. So we're calling parse bytes. Now, what do we want to change here? Well, it's going to be the exact same thing, except for instead of names, we want bytes, right? So instead of constant name, we have constant bytes. And this is going to be our constant name. And instead of name, we want to get bytes. And instead of returning bytes, we want to return name, right? So bytes will be name. All right. There's one more thing that we'd want to switch. Of course, we're no longer formatting bytes 32 string anymore. What we're doing is we're parsing the bytes 32 string. So we want to switch. We want to switch in our name ethers utils from format to parse. So let's go ahead and save this and see if it works. So I'm going to go back into the terminal. And first we're going to get the, and first we're going to create the coffee machine byte version, right? Now, so that works out. We get our bytes. Now let's convert it back. So we're going to do the same thing, node parse bytes.js, and now we're just going to paste this. We're going to paste the bytes. Let's hit enter and let's see what we get. Bytes coffee machine. Okay, awesome. And so we did it. We successfully created 2 converting files that we run on Node in order to convert our bytes into strings and our strings back to bytes. And we can run the whole thing with this ethers library. We don't have to build out all these long algorithms to do it. And then we just call it and slice it up, call it and slice what we need from it. All right, so let's actually convert some proposal names into our byte format. So we already did one. We've got this coffee machine, and we have the name up over here, coffee machine. So let's do one more. So I'm going to go back to node create bytes, and our second proposal was going to be office supplies, right? So I'm going to do office supplies, and we've generated here another byte version for office supplies. So let's say our vote is going to be just over these 2 things. We've got the office supplies and we've got the name, the coffee machine. Now let's go back to our, now back in our IDE, here, let me just bring that out so you can see it better. All right, so back in our deploy, we're going to actually deploy our bytes now. So we have coffee machine and we have office supplies written out, but we can't use this format, right, in our strings. So we're going to get rid of coffee machine and we're going to replace it. We're going to go back in our terminal with the actual byte conversion. See up here for coffee machine. So you want to copy the one for coffee machine, replace it with coffee machine there. And then we have one for office supplies after that. We'll delete office supplies and do the same thing. Copy the bytes for office supplies and paste it in there. All right. And then now make sure that we're in the first account. We want to be deploying because this is going to be the chairperson. So we're going to be deploying from the first account that, you can have a different account number. And let's hit deploy. And there it is. We see that we have a successful contract deployed. So it is reading our byte format. Excellent. And we see that if we check in our console and we open up the information, we can see the status that it was successful. We see who actually deployed the contract, which would be the account number address, to what, which is the name, our ballot constructor. We have our transaction hash number. So we have our contract successfully deployed. And not only that, if we open up over here under deployed contracts, we should see our built-in features that we've added. So we've got the give the right to vote with an address of a voter. We've got the vote, and we see at the bottom here, we've got the winning name and winning proposal. So let's test out these functions now together. Let's see if this smart contract actually works. Let's do some voting. So the chairperson is going to be the first account, right? Therefore, if we go to a second account, we're going to remember, I don't know if you're not sure if you remember, but in the beginning of this video, we said that all these accounts are going to be people who can vote. We're going to pretend that these are all accounts of people in our Telegram community. They're at our company. So let's say we want the second account. We want to give them access to vote. We click on the second account, copy it to the clipboard with the icon right here. Okay. Then we're going to switch back to the first account, go back to give right to vote, paste in the second account, and click on give right to vote. Let's do that. And if we scroll down, we're going to see that we have successfully given the right to vote. The transaction has been successful. Now, why did this work? Because we are the first account. Remember, we are the chairman. So in the give the right to vote function, remember the requirement was that the message sender is the chairman. That's why this is working. Okay. Also, it's working because the second account hasn't voted yet, and the second account has a weight of 0, right? But now that we've given the right to vote, the second account has a weight of 1. So if we try to do it again, all right, if I try to give this the right to vote again, notice that it's not going to work. And it's not going to work because we get a reversion from our give right to vote. So that means that it's working. That should have only happened once. Excellent. So now technically our second account has the right to vote. Technically, our second account has the right to vote. If we go to the third account, and we copy the clipboard. Now, if we were to stay in the third account and we put in the third account address and give right to vote, and we click on give right to vote, what do you think is going to happen? So let's try it. Well, I tried it, and we see that the transaction fails. We have an error. And why are we having this error? Because remember that in our give right to vote, we require the message sender, the person calling this, has to be the chairperson. And the chairperson, if you remember in our constructor, is set to the message sender. And the message sender was the first account. So that means if we want the third account to gain the access right to vote, we have to switch our account back to the first account and then paste in the third account here and give right to vote. And now if we give the right to vote as the chairman, and you scroll down, boom, successful. So now we have given the right to vote to 2 of our members. And you know what? We're not going to give the right to vote to everyone because there's no, I think with just 2 counts, it already gives the message. Hopefully it already provides a little bit of clarity. And hopefully by seeing this in action, now you understand better the give the right to vote and how that's working with the chairman and the message sender, the people who are calling it. So what all these things mean. All right, so now that we've done that, let's actually do some votes. So in order to vote, we need to actually go to those accounts, right? So this account number 2, has access to vote, but only account number 2 should have access to vote. So account number 2 then gets to vote. And now remember, we have 2 proposals. So if this account wants to vote for the second proposal, we can type in 2 and click on vote. And if we scroll down, we're going to see that 2 doesn't work. Now, why doesn't 2 work? Because remember, our arrays starts at 0, and then our second proposal is 1. So 0 is actually 1, and 1 is 2. So if we want to vote for the second one, we can just move it to 1 and click on vote, and we have a successful transaction. Okay. Now, if you're not sure if that confused you, then you need to understand something about arrays and computer coding language in general. Arrays are lists of items, right? So 1, 2, 3, 4. Now, each item, though, doesn't start from 1. We always count in computers from 0. So 1 is actually 0. This 1 starts at 0. This 2 starts at 1. This 3 starts at 2. So very important to remember that. So this is an array, right, where we have 2 different conversions. So this is 0, So this one, or as we would call it in English, our first proposal name, we don't start off by saying our 0 proposal name, is actually our 0 in computer code. That's just how it is. It's something to get used to as a programmer. Okay, so we voted for 1. Now if we switch to our other voter, account number 3, and we also vote for 1, we can click vote. And this transaction has also been approved. Now what happens if we go to account number 4 and we click on vote? So let's try vote. This transaction is not approved. Now why isn't this approved? Because we never gave the right to vote to number 4, right? In the give the right to vote, we add the weight, but this account has no weight registered. This account isn't registered, so it's not going to be able to vote. Only the people in our community can vote that we've given the right to. So that means that our code is secure. It is working in a secure manner. Congratulations. All right, so we've got one final test to do. Here. Can we get the winning name and the winning proposal? All right, well, let's try with the winning proposal first. So if we click on winning proposal and we run that function, there we go. Lo and behold, we see that the winning proposal is 1. And that makes sense, right? Because we had 2 voters and they each voted for 1. So it was 2 versus nothing. Therefore, the winner would be 1. Excellent. So that is working. Now, what about the winning name? If we click on winning name, we see we get this bytes. Now, the winning name should actually be office supplies, right? Because office supplies is the second one. Office supplies is our 1. So let's go ahead and go back into our terminal. Well, before we do that, let's copy the bytes. So we're going to copy this, and now we're going to go back into our terminal. And from our terminal, we're going to run node parse bytes to convert back, right? .js, and we're going to paste in the number. Let's see what happens. And there it is. Amazing. Okay, bytes is office supplies. Our voting system is successful. Congratulations if you coded along and you made it this far to the end of this lesson. You have successfully coded out a smart contract DApplication for voting implementation. All right. Now, hopefully going through these steps of the deployment is actually giving you a better sense of how these requirements, how the looping for the proposal, how the deployment of the constructor, how the bytes, how transferring the bytes, converting, how these things actually work. For me, it's all for myself. It's always the best when I actually see it happening in real time. You know, I'm not an abstract thinker when it comes to code. I want to actually see things functioning and working before my eyes. So hopefully going through this has helped you on your path to writing smart contracts and developing your Solidity skills. Now for extra bonus, what you could do on your own is try and figure out an additional voting implementation. Essentially, when we think about smart contracts, a good takeaway here is to consider that what we're building is not just to exist within the smart contract. What we do is not necessarily to exist just within it, but to interact outside of it as well, all right? And this is an excellent example of doing that because we are getting a lot of account interaction. And these account interactions, and the more interactions we add, the more we have to think about requirements and safety, authentication, and these restrictions to keep our DApplication secure and working well. Okay, so I hope you enjoyed this video and you got something out of it. Great work getting to the end of this, and I look forward to seeing you in another video. Okay, bye-bye.